So we're writing the equations of parallel lines. So not just writing the equation of any line, but just of a line parallel to another line. Things we need to remember and things we need to know. Parallel lines have the same slope. So same slope is what we want to remember for parallel is same slope. So as long as your m values are going to be the same in both of these. So when it's given to you in slope-intercept form, like our first example, y equals 2x plus 4, you need to identify that your m value is 2. So if our m value is 2, then the parallel slope, which would be the same, is going to be 2. So our m value in our new equation is going to be 2. And then it's going to pass through, and remember this is x and y, so 2 and 3. So one more time, parallel slope means same slope as given to write a line that's parallel to that line. Because again, remember, parallel means that they will never touch. So if you're graphing a rise over run of 2 over 1, 2 over 1, 2 over 1, to keep the line from running into it, it needs to have that exact same slope. So we're going to plug in those variables. So it's y equals m times x plus b. So again, we have everything. We have the slope, we have a coordinate, we are just missing our y-intercept or our b value. So if we solve this, it's going to be 2 times 2, says 3 equals 4 plus b. We need the b by itself, so we're going to move the 4 over to that 3 side, and we're going to subtract because that's the opposite of that positive to get these guys to cancel out and get b by itself. So b is going to equal to a negative 1. So we're going to take our parallel slope and our negative 1, and we're going to plug it in. So y equals 2x minus 1. Because again, all you need to write the slope of the slope-intercept form of an equation of a line is the slope and the y-intercept. In this case, you have the slope given, but you have to remember that parallel means the same slope. All right, so we're going to do another one together. So parallel to y equals 3x plus 12. So identify that this is our slope. We know that parallel means it's going to be the same. So we know that our slope is going to still equal 3. We have an x and a y coordinate. So it's going to be negative 2 for our x value, and our y is going to be 5. So we're going to plug in. So our y is 5, equals m, which is 3, times x, which is negative 2, and we need our b value. So it's going to be 5 equals a negative 6 plus b. Add 6 to both sides because that's a negative 6. So we need to get b by itself. 11 equals b. So we now have all that we need. We have our slope and our b. So our slope is going to be y equals 3x plus 11. And now you've written the equation of that line parallel to. So this equation is parallel to y equals 3x plus 12. And one you know because you solved it, but because they have the same slope for parallel lines. And then it's just like when you're given the slope and given a point after that. The only addition from our previous lesson is making sure you remember parallel lines have the same slope. So we're going to try number 2. And if you're feeling froggy, pause it and try it yourself. There's only 4 total, so might as well start now. So parallel, that means we're going to have the same slope. So this is my slope. So the slope of my new line is going to be 1/2. I need an x and a y. So I have x and y. My x is 4. Y is 6. So we're going to solve it. And that's where we bring in our y, which is 6, equals m, which is 1/2, times our x value, which is 4, plus our unknown y-intercept. 1/2 of 4 is going to be 2. Subtract 2 from both sides. So we get b by itself. So 4 equals b. And so our y-intercept, so we have our slope of 1/2 and our y-intercept of 4. So our equation is 1/2 x plus 4. And that equation is parallel to the given equation because they have the same slope of 1/2 x minus 2. Now, remember, we have Desmos and things to check this. So if I was to plug this into Desmos and graph it and plug this into Desmos and graph it, you should see them running parallel to each other and not appearing like they're going to even remotely close in. It should be very evident that they are not going to touch. That should be no question in case you're going to check in. All right, number 3, if you didn't do number 2 by yourself, pause it, try it. So we have our slope, which is going to be a negative 1. We have our x and our y. We're going to plug all that in. So y is negative 6. Our slope is a negative 1. And our x is 3. Negative 1 times 3. It's going to give me a negative 3. We don't know what our b value is. We're going to add 3 to both sides because that's a negative 3. We get negative 3 equals b. So again, we have our slope and our b value. So it's going to be y equals negative, and you put a 1 or just negative x plus a negative 3. And again, as I've said before, that's going to be y equals negative x. Probably just minus 3 more times than plus a negative. And that line is parallel to y equals negative x plus 12. So your y-intercept is the only thing that actually changes in your slope-intercept form when you are graphing or writing the equation of two parallel lines. Last but not least, number 4. All right, come on. It has a funny fraction of 3/4, but I think you've got this. Pause the video. Try it. So our slope is going to be negative 3/4. X is going to be a negative 11, because that's x, and that's my y, and y is going to be 3. So we're going to plug this in. So y is 3 equals negative 3 over 4 times a negative 11 plus b. Negative 3 times negative 11 is going to be 33 over 4. 3 equals plus b. Because we are solving for b, I'm going to turn that 33 divided by 4 into a decimal, and that's 8.25. And I'm going to move it over, which means I'm going to subtract it. So it's going to be 3 minus 8.25. which will give me a negative 5.25 equals b. So again, now you have your parts, you have your slope, and your b. So it's a negative 3/4, and we like our slope as a fraction because you need rise and run. And then our y-intercept, more times than not, you prefer as a decimal just to make it easier to graph. And it can be plus a negative, or again, y equals a negative 3/4 x, which is the same slope because we are looking for a line parallel, and they have the same slopes as your previous given, with a y-intercept of a negative 5.25. Great job, guys. That's parallel lines, same slope. Plug in your x and y, solve for b, pull the portions you need, and put in slope-intercept form.